Hello everyone. The last lecture we have seen was that limit and sequential criteria for the existence of limit, and today's lecture we will see what are the rest property of the limit topic. So there is a theorem that this is called sign preserving theorem. I am saying that shortly I am saying that what is that one. If limit extends to c fx is equal to L, if L is positive, then there exists a neighborhood of C where fx is positive. Similarly, if the limiting L is negative, then there exists a neighborhood of the C where the fx is less than 0. So we will prove that one, proof of the theorem. First one, given L is positive. Okay, L is positive. So I choose an epsilon greater than 0 such that L minus epsilon is still positive, and I can find that epsilon. Okay, L minus epsilon is positive. Now since limit extends to C fx is equal to L, that means there exists a delta positive such that fx lies between L minus epsilon ro L plus epsilon for all x belongs to the deleted neighborhood of C intersection with D. Okay, since L minus epsilon is positive, so this is greater than 0 is less than L minus epsilon is less than fx, implies fx is greater than 0 for all x belongs to the deleted neighborhood of C intersection with D. Okay, we have just proved that fx is positive. Second, given L is negative, choose an epsilon positive such that L plus epsilon is still negative, and I can find that epsilon. Just see how we have 0 here. L is somewhere less than 0, means L is on the left side of the 0. So I can find an epsilon such that L plus epsilon is also negative. Again, same that limit existence, so there exists a delta positive such that fx lies between L minus epsilon to L plus epsilon for all x belongs to the deleted neighborhood of C intersection with D. Now since L plus epsilon is negative, okay, that means fx is less than L plus epsilon is less than 0, implies I can say that fx is less than 0, and that is true for all x belongs to the deleted neighborhood of C intersection with D. So we have shown that if L is positive, so we have a neighborhood of C where fx is still positive, and if L is negative, then we have a neighborhood of C where fx is still negative. Now we'll see what's the algebra of limit.